stuff.
Quiz on 9.1 to 9.3 is on Friday, and I believe we stopped here on the third kind of error in
BBCC, this is Dr. Mooney. Please pardon this interruption. Just a couple of quick thoughts. The first is, teachers, we're going to ask that you play the video that Mr. Goodwin sent out yesterday morning today during class if you didn't have a chance to. He will send that video again shortly. It's only about 3 minutes, but we're asking that we want to make sure every student has an opportunity to see that during second period today. Also, students, I just want to make you aware of a couple of things that we've been doing lately. One of the big concerns that we've had is people letting others in the doors. So just want to make sure you are aware that we are suspending students when they open the doors for others. So please make a good choice, students. If you're arriving late, come around to the main entrance. We'll let you in, we'll give you a pass, and we'll get you in class, and there'll be no harm done. Thanks so much. Have a great day.
Yeah, so things are getting a little more strict. We also request that you do not leave class between bells. So if you don't need to, absolutely need to go, don't. All right, so 3 kinds of error, we were on the third one. Tomorrow is SATs, so there's no class, and Thursday I won't be here. So, after the SATs, it's generally considered non-instructional, but you're in class. If you want to come here 6th period, or 5th period actually, 5th period I don't teach, but I'll be here if you are not completely exhausted from having taken SATs. And 6th period I also have calculus, so if people have questions and you want to have some review time or whatever, you can come by. 5th or 6th period after the SAT. On Thursday, I believe some kind of Delta math as a preference, but again, sorry, I won't be here. All right, so just a quick recap. If it's geometric series and you only use the first 2 terms to do your approximation, add up, do the geometric infinite sum to find out, okay, so my error is, my answer's gonna be this far off. If it's an alternating series, George, what's the thing that has to be alternating to make it an alternating series? The sign.
Yeah.
Positive, negative, positive, negative, positive, negative. So if it's not geometric, but alternating, the biggest mistake, the biggest error is the value of the first ignored term. Okay, value. If I centered things down at 3, and I'm using it to approximate about things when I plug in x from 2 to 4, we're gonna plug in that 2 or that 4 to see where's the, which thing makes the error biggest. Okay, the third flavor is this Lagrange error. And if got ahead of myself. If I said, what is the polynomial that approximates this function at 3? 7 x minus 3 to the 0 over 0 factorial plus 2 x minus 3 to the first over 1 factorial minus 4 x minus 3 to the second over 2 factorial. And if I stop there, the first ignored term, Cameron, pick a number for me.
6.
First ignored term would have been third derivative x minus 3 to the third over 3 factorial. if I generated one more term, that's this ugly business. Make one more term, actually all of this. That's the biggest error. And to understand what this Z is, because it's not the center, it's, if I was saying, I'm using this polynomial to approximate any values from x1 to 7, what makes that number biggest? Plugging in 1 or plugging in 7, the 7's gonna make it a bigger error, so I'm gonna use that. Okay. Let's try the example that's in your packet. Can you guys do part A? Generate the Taylor polynomial degree 2. And that really, you gotta do the derivatives and integrate. So there is no shortcut or cheating way to force this to look like a geometric thing, so I gotta go old school. Do the derivatives, evaluate at the center, and then create the polynomial. Function and the polynomial need to have the same value, they need to have the same first derivative at 8, they need to have the same second derivative at 8. That's the way to create it. Are we okay with that pattern? Okay. This Lagrange error. I see it just like alternating, but I gotta, what is the next term? Okay, I had to generate it. I need to do one more derivative. That derivative, x minus the center to the next power up, third, over 3 factorial. I left this blank, because that z, it is, what is gonna make that the biggest value in the x's from 7 to 9? And to make it easier, looking at it in the denominator, what's the biggest number, 1/7 or 1/9? 1/7. So, do you think 7 to the 8/3 is bigger than 9 to the 8/3 when it's in the denominator? Like, sorry. So when I'm dividing, there we go. And there's an x here as well. Plugging in the 7, plugging in the 9, I get the same value, so it didn't matter. So my error is gonna be 10 over 27 times 7 to the 8/3 divided by 3 factorial. Why did I ignore this? Well, 1 to the 3rd is just 1. So that's Lagrange error.
You choose 9.
Yep, I mean, choosing 9 down here, no, because that makes the error not as big. So we wanna pick the number in that range that's gonna make it as big as possible. Because we wanna know what's the maximum error. Like, if this is a safety critical thing, we're doing brain surgery, what's the biggest mistake? We wanna make it, choose the numbers that make it as bad as possible and still say, all right, that's within my tolerance level, I'm okay. Okay, can you guys try these? And this is how far you can get on your own. I'm also going to hand out the AP error problems and see how much of that we can get through. Then we integrate up.
what does it say when you just use this, it's just a, I think you do.
So that is saying we use the first two terms, right? On this example? First two? Alright, so looking at it, these are geometric. I'm multiplying by negative x up top and the bottom is going to be 4 times 7. Okay, so it's not geometric. Are the signs of this going to forever alternate? So how do we do the error? First ignore return. What is first ignore return? And then you stop the time. That's your hit. Okay, so in this, first one, like what kind of error is it? Is it geometric? I don't know, I kind of need to know what the whole series was, just looking at two terms isn't enough. I don't have it memorized, and remember, if you have the second packet, on the back of the second packet, these are listed out, if you wanted the shortcut, but I'm like, all right, I'm just gonna regenerate it. I'm gonna do the derivative and recognize that this looks like the infinite sum a over 1 minus r, and if the absolute value of negative x is less than 1, strictly less than 1, not equal, then it'll converge. This guy, so looking at the series, is it all, is it geometric, what did we say? No. Evan, is it an alternating series? It is. It is. So how do we do, Nathaniel, how do we do error with an alternating series?
You find the next term and then
Found it.
plug in like maximum possible.
Okay, so if I'm using this series, for those x values, right, what am I gonna plug in?
0.1.
Okay. By the way, this is a non-calculator question, and they are wanting, not that as an answer. Okay. If you are allergic to decimals, I don't like decimals myself. 0.1 is 1/10. 1/10 to the third, well, that just means 3 zeros down there. My error is 1 over 3,000. Okay, oops. And the reason that I say something about this, you can leave this in it as an answer, but they will ask, show that the error is less than 1 over 1,000. And are you certain? Like, do you know? So they'll ask. Fourth order polynomial, what does that mean? Fourth derivative. Do I need to do derivatives to do this one, or Julie, how am I gonna create this? Am I gonna do a whole bunch of derivatives, or does it look like something that I can create using geometric, or do I have to? Looks like the sum, so let's force it into that pattern. What's the A? What's R? Okay, so create the pattern. First term is 2 times -3x times -3x. 54. Oh. 60, 72. What is 162? I really ought to fix the numbers for this one. Yeah, thank you. Roman, how do I do the error on this?
That's my question.
Okay, so we have 3 kinds of error. Geometric, where we sum up the tail end. Alternating, where we take the first term that we ignored, which is what we did up here. And Lagrange, where we don't know what the next term is, we need to create it and then work with that.
This is like alternating.
This is alternating? Yes, it's alternating, however, we're gonna do geometric. So you gotta be careful, how did I create it? Well, Julie's like, it looks like this, so geometric. So I need the next term. The next term. Over 1 minus R. This isn't my error term, it is the actual error. And we need a calculator for the rest of this, so don't really want to do that. But again, since I won't be here on Thursday, I want to show you that worksheet that I just handed out is all the AP questions, like not all, but an example of how you might be asked about error. Things that are on the quiz on Friday, doing the geometric stuff with just strings of numbers, as well as things that are strings with variables in them. Being able to find the infinite sum, knowing when the infinite sum happens and when it doesn't. Being able to generate the Taylor series, and then figuring out the different kinds of error. Oh, will you be permitted to use, I don't know. I haven't written it yet. I cannot guarantee that you get a calculator. So can you guys try the error worksheet? Is this it?
Yeah.
Yeah. Yep. Ben pretending like he really wants the worksheet.
Ms. Pascal? I have a question. For B that we just did, can you like plug in a number for X and then you get it like an actual number?
Right, so here, if absolute value of negative 3x. So as long as I pick something between negative 0.3 repeating and positive 0.3 repeating, which 0.1 fits in there, if I pick a number in there and use it to approximate this thing, like, it'll be pretty close. How
Okay.
far off will it be? If I plug the 0.1 into this, I'll find out exactly how far off.
Okay, thank you.
I had to write out all the individual buttons, the factorial, and 20 times 6, so it's I'm just gonna six is 20 times 3.
Yep, that was 10.
Yep.
So, like, process-wise, what you said.
Why do you have this? Like, what is this?
This equation?
Yeah.
It's just like, it's the equation that gives you the error because like you plug it into the first forgotten term as like the top value and like the sum of each.
Okay. I have no idea when we did that. but
It was like the first thing, and it's like because like normally in the sum equation, like the top number is like that, like the first number that it starts with, and then like it'll calculate how much is added up after that. But like for this, it's like you're starting at the first one that they didn't use. So
No, I literally started using the sum equation.
yeah. My sister has research jobs right now. I feel so bad. I feel so bad. lot more annoying.
I read it a lot of times and I
Yeah.
kind of like,
Yeah, that's so real.
Oh, yeah, I got that. No, it's, I do.
Here we go. So for this problem, from sin x, x minus x cubed is 3, 5, that's just it, 5 x by x. So you just get sin x